So in the last class we talked about autoencoders. We talked about the different types of autoencoders. I'm just writing AE here, okay? So what are the different types of autoencoders that we talked about? We talked about undercomplete. Then we talked about denoising. We also talked about sparse, right? So now we know how autoencoders work, okay? So we know the different types of autoencoders, but here is the thing. Although we know about autoencoders, we do not yet know about how Word2Vec works. So we know the architecture behind this, okay? So we know how Word2Vec works using autoencoders. Like we know that Word2Vec works on autoencoders, but we still do not know how Word2Vec works, alright? So our task is basically now to understand how Word2Vec works. Okay, so now before we go into that, let me tell you there are two algorithms for Word2Vec, okay? So Word2Vec itself has two different algorithms and you will be learning about both of those. So we have something known as Tableau and we have skipgram. So these two are just opposite of each other and we will be talking about both of these, okay? So Tableau stands for continuous bag of words. And then you have skipgram. So there is no short no long name for this. So you have Tableau and skipgram, and Word2Vec basically works on any of these algorithms. So we'll have to understand how it all starts. So the basic thing is basically what we require is an autoencoder. So the whole task is based on autoencoders because our main task is basically compressing. See, till now we can use bag of words. In bag of words what happens? You can use one hot encoding. So let's suppose you have a sentence. The cat sat on the wall, right? So in that case what will happen, if suppose my whole point of this is, let's suppose I need to find out the value of or the one hot encoding for cat. So in that case what will happen? So 1, 2, 3, 4 and 5. So here if this stands for this stands for cat sat on wall. So in that case what will happen? This will become 1, rest will become 0. In the same way if I do that for sat, so in that case what will happen? This will become 0, 0, sat will become 1, then 0 and then another 0, okay? So what the whole point of this is basically, see, let's say take another one, let's say on here. So in that case what will happen? This will become 0, 0, 0, on will become 1 and this will become 0. So what the thing about this is, see, we need to understand. Let's find the difference between cat and sat, okay? So the difference here is this. So 1 minus, so you have to find out the difference from here. So this is not a lot if you think about it. So this will be 1 minus 0 whole square plus 1 minus 0 whole square, right? And then you will underroot this. This is the L2 difference. If you do that, the same thing for cat and on, the difference is still going to be the same. So here is the problem where it happens, okay? See, cat and sat, the way they are related is not the same way in which cat and on are related. However, if you see, the difference between each of these terms remains the same. So that is the problem with bag of words, right? Bag of words, see, first of the problem is it does not understand the context. Secondly, for these frequency based methods, right, you do not understand how one word is related to the other word. Like I showed you right now here, what happens is, see, here and here, the difference between these two words, okay, or the so the distance between these two words is the same as the distance between cat and on, and that distance is the same as the difference between sat and on, right? So this is not going to work because it does not actually understand how different or how unique each word is on its own, okay, or how unique a particular pair of words is. So that is why we need what is known as the autoencoders and Word2Vec, okay? So now let us start with understanding how Word2Vec works. So let us just take the first sentence here. The cat sat on the wall, okay? So this is my sentence. So the first thing that you have to do is basically divide this into context and focus words. So let's suppose my focus word here is sat. So this is my focus word. In that case what will happen? And let's suppose my context word or context window is 2. in that case what will happen? So two words before the focus word and two words after the focus word, these two will be taken into consideration. Okay, so now if sat is my focus word, in that case these two will become my context words and these two will become my context words. So you have the context words, you have the focus word. Okay, so now let us try and use some other word. So let us say I am using the word cat this time. So this is my focus word here. So in that case, since here you do not have another word, so in that case only this will be the context word, and here these two become your context words. So in that way what we are going to do is, for all the sentences of the entire vocabulary, the first thing that we are going to do is basically divide it into focus word and context word. So this is your focus word, context word. In the same way, next you will have another focus word with the context word. So this is going to be the whole point of this. Okay, so you will have a whole dictionary or a whole list of focus and context words. Okay, so this is the very first task. See, even if you use Tableau or skipgram, this is your first task, that is finding out your context and focus words. This context word will basically depend on your window, what size window you are taking. If I change the window size to 3, in that case for sat being my focus word, my context word here will be the cat and here it will be on the wall. Alright, so that you need to understand what you are making your context word and what is you are not making your focus word. So that depends totally on your context window. Next, after you have this, the next thing that you will be doing is basically, let's start with Tableau first, understanding Tableau. So Tableau stands for continuous bag of words. So now we'll be understanding how this is related to an autoencoder, right? So the very first step is finding out your focus and context words. The second step is basically converting each word to one hot encoding. So that is your second step, converting into a one hot encoding. So here, if you think about this, so these are the different one hot encodings for cat, sat, on and so on. So we'll be having something like this. So let us write this again. The cat sat on the wall. Okay, so here first start with the. So what will be the one hot encoding in this case? Right, so in this case this will be of one hot encoding, the rest will become 0. Then you have cat, in this case what will happen? This will become 0, rest will all become this will become 0, this will become 1, the rest all becomes 0, right? So in this case you will have all the one hot encoding. So that is the second step. After you have found out the focus and context word groups, next you will be converting all of these words into one hot encoding. Okay, and this will be equal to, let's suppose, V dimension. V dimension basically means the number of unique words that you are going to take. Okay, the size of your vocabulary. So I can say let's say I take 10,000 words. Okay, so in that case my V becomes 10,000. Here for this case we are taking 1, 2, 3, 4, 5 and 6 words. So my V dimension becomes 6. Right. So that is the next thing. So now what you are having is basically, you are having different words. Let's just suppose for now we have 3 words. So you have the, cat, sat. Okay, and all of these are V dimensions. V, that is 6 here. So the next thing that you are going to do is basically, now all these steps by the way are for Tableau, just remember that. We will be talking about skipgram also, but for now we are talking about Tableau. So you have these and they will all be fully connected. So you have fully connected layers here, and this is basically an n dimension. So the weights here will be in what format? If you think about it, what will be the weights be here? So this weight is basically V and this is n dimension, so this is V cross n. Here you will get 1. In the same way, since this is also fully connected, in that way what will happen? This will be W V cross n. Here again this thing will be what? W V cross n, right? So here v is basically this dimension size and n is because we are getting this. So you are having different weights here. Okay, so you will have v weights, sorry, the number of terms in the vocabulary, yeah, v weights, and it will be of v cross n size. So the number of weights will be v, and that is v cross n. Okay, and then once you have this, the next thing that, so this is basically n dimension. This is where you are reducing the whole thing. This is the part where autoencoder is basically used. Then this is followed by here. So okay, I forgot to mention this, but here is the thing. When we talk about CBOW, right, so the whole point of CBOW is basically given different context words, you have to predict the focus word. So that is the whole point of CBOW. So that is the basic thing in which this whole thing works. All right. So I am so sorry, I forgot to mention that, but the whole point of CBOW is given different context words, you have to predict the focus word. Okay. So for this question, if we are taking sat as our focus word, in that case what will be happening is you will be given, your model will be given the cat on the wall or whatever, the cat on the as the context word, and you have to predict the focus word, that is the sat here. That is the whole point of CBOW. So that is what we are going to do here. So this here basically you have all the context words. So since our context window is 2 and we are taking 4 context words, so this is 4. So basically you will have the, cat, on, and then there will be another one for the. Because these are the context words for word sat. If we think about it, for the word sat, the context words are the, cat, on, the, right? So that is what we will be taking here. So now that you have the context words, you have the context words converted into one hot encoding. Next you will connect it all into along with an n dimension layer. Okay. So you have an n dimension layer and all these are connected to it. Okay. And by the way, all these are of v sizes or v dimensions. So now you have different weights, each weight matrix, like for this one the weight matrix will be v cross n. In this way the weight matrix here will be v cross n, and so on and so on. Okay. So now this is an n dimension. Here you have a v output. So this v output basically is one hot encoding for sat. Okay. This is my focus word that I have to predict. These are all the context words for the particular focus word. Alright. So this sat is what I have to predict. So this is v dimension and this will also be fully connected. Okay, here is the thing, by the way, if you ever get something like this, right, if this is how you are getting, this means fully connected. Okay, so this basically means the whole thing is fully connected. So this n dimension, and here you will get, this is a one hot encoding for the word sat. Okay, so now since that is done, now what will happen, the weight will be here n cross v. You got a n cross v here. So now what will be, so now what happened is basically, if you think about this, this is an autoencoder. See, this is the actual size that has been reduced to n dimensions, and what you get is an output of v dimensions here, which gives you the focus word given all these context words. That is the whole point of this, right? So what is happening is basically it is getting reduced to n dimensions. So now if you think about this, this weight will now be used to find all your embeddings for these context words. If you think about it, so you will get what, w n cross v. V was basically the number of dimensions and n was, or v was, if you take that as dimensions, all right, there is one more way in which you can represent this. V also represents what? V represents your vocabulary size. So here is the thing, why is the dimension and vocabulary size equal? See, you are converting into one hot encoding, right? If you convert it into one hot encoding, the dimension and vocabulary size will be 1, because each particular space or each value here represents one particular word. Since this v will be, this dimension will be equal to the number of words in your vocabulary. Okay, because each space or each value or each dimension represents a particular word. So that is why it is going to be the same. So you have v dimensions and you are getting w n cross v as the output here. Right, your output here is n cross v. So what you are going to do is basically, if you think about it, you are having something like this. So you have first, so let's say you have 1, 2, 3, this goes on till n, and you have here 1, 2, 3 and this goes on till v, right? So here is the thing, Now this is v means number of words. So this is, let's say, the first word, this is my second word, this is my third word, and this goes on till the vth word, right? So these are the values that I am getting. If you think about it, we also talked about this in autoencoder, but here is the thing, this is your vth word, these are all the words from the vocabulary, and all of these, if you look at each column, it is of n dimension, n size. So what happened basically is your v dimension words are now converted into n dimensions. You understand what is happening? So let us go back one more time. Let me explain one more time properly. So the very first step, what happens is basically you are going to find the group of focus and context words. So you have focus and context words, you have the groups of that. Next you are going to do is basically convert it into one hot encoding. So now you have one hot encoding of all these. Next what you are going to do is basically you have to decide whether you are going to use CBOW or skipgram. Since we are using CBOW, so what we are going to do is basically create an auto encoder. So how will our auto encoder look like? It will look like this. So here you have different context words. So these are all your context words, and each context word is of v dimension. V is basically the size of your vocabulary, right? So this is that. Next what you are going to do is you are going to connect it to an n dimension neuron. So you will have different fully connected layers here. So this will be connected in this manner, and then you will have this connected in this manner, and so on, right? You get the idea. So these are all fully connected. So for every one, so let's say this is here. So for every value here you are going to get a W. This is v dimension, here you have n, so you are going to get v cross n. So these matrix are you are going to get for each and every context word. So now you have that will now finally be, this will finally be now connected to your focus word, because from the context words you have to predict your focus word. That is the whole point of CBOW. So now this focus word is again of v dimension, so this will all be fully connected. So in that case, what weight matrix are you getting? W of n cross v. Right, now you have n cross v. Now what you can do is you can represent it in this manner. So this will be n rows, so this will go until n, and this will be v columns, right? So these columns will basically, what will these columns represent? These columns will represent your number of words. For each word now you will be getting what? Each column will be basically a dimension or a representation, a vector representation of v words for n dimensions. So each word is now represented in n dimensions. So the whole point of this is, see, whenever you are doing this task, the whole thing is basically you need to change the value of n, because if you think about it, in any point of time this v is not affecting. Your v can be of any size, but you want vectors of a particular size. So by default you can use 100 or 200 dimensions. That is used a lot in Word2Vec. So you have 100 and 200 dimensions. So what you can do is basically this n you can decide it to be 100 or 200 depending on your requirement, right? And then this v can change according to your requirement. Okay, this is totally up to you how you want to change it. So now let us talk about skipgram. So now let us talk about skipgram. So skipgram is basically the opposite of CBOW. So what that means is basically, in skipgram, like in CBOW, what you had to do was basically from given context words you had to predict focus word. In skipgram, from focus word you have to predict context words. So in skipgram it is just going to be the opposite of it. Okay, so this is not going to take a lot of time. Let us understand how this happens. So you have one focus word here. So the first two steps are going to be the same, by the way. So the very first step will be basically identifying a group of focus and context words, and the next step will be converting into one hot encoding. Right, once you have that, what we are going to do is basically we are going to make the auto encoder now. So this will just be the opposite of the auto encoder that we were using in CBOW. So here you have a focus word. So this is v dimensions. So once you have that, here this will be connected to an n dimension. So don't mind my drawing. So this will be connected to an n dimension layer. This is your hidden layer here. So this will be connected. By the way, this n is going to be smaller. Wait, let me just. So yeah, this is better. So you have v dimension. This will be connected to an n dimension, and this again in turn will be connected to different softmax layers. So I'll say how this happens. So what happens is, first, see, you have focus word here. This is of v dimension. This is connected to an n dimensional layer. So what are the weights you are getting here? You are getting v cross n. These weights are done. Next, what you have to do is connect this n to different softmax layers. So each softmax layer is basically, each softmax layer is responsible for predicting each context word. So the number of softmax layers that are going to be there is equal to k. K will be basically equal to your context window. In this case, it is 2. Okay. So these words are basically going to be the number of context words that you are going to use. Okay. So in that case, that will happen. So you have softmax layers. Each softmax layer is now responsible for giving out a context word. So you have context words for each and everything. So in this case, what will happen? So this will be basically what you will be getting, different weights, different sizes. What will be the sizes? So here you will have what? N cross V. Then for this again you will have W n cross V. Here again you will have W n cross V, and so on. In this case, what will happen? For finding out the values or the embeddings, what we will do is we'll take the weights from here. Okay. So this is the place where we will be taking the weights from. Not here, we will be taking it from here this time. So you will have a weight matrix of W V cross n. So this time how it will look like? So this is your 1, 2, 3. These are the number of words that you are using. And then here you have 1, 2, 3, 4. This is your nth dimension. And n can be equal to the size that you want. V is basically the size of your vocabulary. So for the first word, this is my n dimensional vector. For the second word, this is my nth dimensional vector, and so on. Right? So in this case, you are getting all the weights or all the values, all the embeddings from here. So this is basically the difference between CBOW and skipgram. Okay, so this is the main architecture. There are a few differences. Let us talk about that. First of all, let us talk about the number of weights that will be used to calculate. So let us talk about the number of weights. First, let us talk about CBOW. So in CBOW, if you think about it, where are the number of weights? So here you have CBOW. So here you have this number. These are the context words, and it is equal to k. K is basically a context window that we are using. So this will be equal to k times, what is this? So k times you will be getting V cross n. Let us remove the W. So k times you will be getting V cross n, and then here you will be getting another V cross n or n cross V, whatever. It's the same thing because it is multiplicative. So if you add this, so the total number of weights for CBOW is basically k plus 1 times V cross n. So these are the number of weights that you will be using for CBOW. Now let us talk about the number of weights that you will be using for here, for skipgram. So in skipgram, see, in skipgram you have 1 V cross n first. This is V cross n here, and here you have k times. So this will be equal to plus k times. Again n cross V or V cross n, it's the same thing. So in this case, what will happen is basically you are going to get k plus 1 times V cross n. Right? So now that you have this, you have to understand. See, the number of weights for CBOW is k plus 1 times V cross n. For skipgram, it is the same thing, k plus 1 times V cross n. But it is computationally easier to calculate skipgram. Even though the number of weights are easy, computationally it is easier to calculate CBOW. So why is that? See, think about this. In skipgram, you have to predict so many softmax layers. Okay, you have to predict the values for each and every softmax layer. So that is one problem in C. Wow, if you think about it, it just had to predict one softmax layer, right? So that is one big problem, obviously. See, it is always, if you think about it, if you have been given the words the cat on the wall, so you will be able to somehow predict sat, but given sat you have to predict the cat on the wall. That is kind of difficult. So that is the problem here. So it is easier to use CBOW, although skipgram is also used depending upon the case where you are working at, but this is basically the whole point of this. So let us talk about one more thing here. So just a quick recap of skipgram. So what happens is you have the focus word, and from the focus word you have to predict the context words. So the first few steps are going to be the same. You are going to make a group of focus and context words. The next step is basically going to be converting it into a one hot encoding. Once that has been done, you will be using the focus word and then you will be connecting it to an n dimensional layer. This is your hidden layer here, and once you have that, then what you will be doing is basically connecting it to k different softmax. K basically is the number of context words that you will be using. Once that has been done, it has been connected, and then what will happen is basically you will be finding out the different values, and depending upon that it will be able to say whether this context word is related to this word or not. And then finally you will be using the weights from here v cross n to find out the embeddings of those words. Okay, so that is the whole thing. Now the main point of this is, see, you are requiring k plus 1 into v cross n, right? Here let us talk about this. V is basically your vocabulary size. This is always going to be huge. K is basically the context window size. So let us say we keep k as 2 here. So you have 2 plus 1, and vocabulary size has to be minimum at least 10,000. So 10,000 into n. N is basically your number of dimensions that you want. Let us say we keep it at 100 at this point. So you have 3 into, this is what? 10 to the power 6. So these are the number of weights that will be required, okay, just to calculate something as small as 10,000 words. So this is going to be a problem if you think about this, okay. If you think about it in this manner, you will understand that calculating so many weights is not possible, like it is not feasible. It is going to take a lot of time. Hence, to solve this problem, the researchers, they came up with some optimizing solutions. So what are the different solutions that they came up with? So the one solution that we are going to talk about, that is known as the binary tree solution. So what they did was, see, you have all these context words, right? You have n dimension here, and you have to predict a word, focus word here. And if you see about this, this is for one sentence, so there is going to be a lot of such things. All those will be connected and you will have to predict different focus words. In that case, what they did was basically, see, instead of doing that, what they did was they divided it into a form of tree. So you have this tree here, binary tree. Alright, so this is the input, this is where your output will go, and this is where the output gets here. So you have the output here. So now here, instead of predicting the value for each and every word, so let's suppose this is word 1, this is word 2, this is word 3, this is word 4. So instead of predicting the values for each and every word, what they did was, in the output they have to predict whether the word is in the upper half of the tree or the lower half. So let's say it's in the upper half, so it will go here. Next, what will happen is it will again ask whether this is in the upper half or lower half, and in that manner it is being able to predict. So in that case, it does not have to go and give the predictions for all of these words. Alright, so that is one way in which it was optimized so that it can handle these many weights. So I know this is a lot, so let us take it slowly one by one. So we talked about CBOW, we talked about skipgram. We talked, these two are the algorithms that are used for Word2Vec. So Word2Vec, basically what Word2Vec contains is, you have different words, and for each word you have a corresponding vector. Alright, so to convert this or to find these values, we will be using either CBOW or skipgram. Okay, and then once after we understood this, we talked about the problem that is with optimization. So how we can optimize using or training Word2Vec. Alright. So we talked about all these threes. Once again, let us go back and understand each and everything. I know I'm going through this a lot of times, but that is because so that you can understand. So the very first thing that you do is find out focus and context words. Once you have these, what you are going to do is basically you have to use all the context words to find the focus word. That is your whole problem of CBOW. So this is context word 1, this is context word 2, 3, 4 in that manner, and you have an end dimension here. Okay, so all of these are connected, fully connected here and here. Then you have here, 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 and so on. So this is W. If you talk about this is V dimension. So this is V cross N because this is N here. Okay, so in this way you are having so many V cross N's, and this is equal to, so V cross N's, and this will be equal to the number of context words. So let us say the number of context words are K, so it becomes K into V cross N. So then out of all these context words, given these context words, you have to predict the focus word. So focus word is again V dimension. So here what you get, a weight matrix. These matrix will be equal to N cross V. From this matrix, what you can do is further expand this, and each column will now represent an n dimension vector for a particular V word. Alright, so this has been done. So this is all about CBOW. In skipgram, what happens, the whole thing reverses. So you have a focus word, it is connected to n dimension. So it is connected to n dimension layer, and each of this is again connected to different softmax layers. The number of softmax layers is equal to K. K is basically the size of your context window. Okay, so it is connected here to different softmax layers, and each softmax layer is basically responsible to predict one context word. Okay, so here your weights will be V cross N again in the same thing, and here it will be same thing. Here the output that you will be getting, this value will be used for, so if you think about this, so you have your focus word here. Now this is connected to an n dimension. This is further connected to different softmax, right? And this here, this focus word, so these softmax layers are used, and this weight here, so this basically, this here V cross N, this will now be used to find all the different values. Alright, so these values, if you expand this, what will be the whole thing of this matrix? So you will have V words here. So you will have 1, 2, 3, 4, this goes on till V, and then you will have n dimensions here. This is your nth dimension. So now each row will be an n dimensional representation for a particular word. So this will be representation for the first word, second word, third one, and so on. And then we talked about optimization problem. The problem is that basically here you can see that the size is very large. The number of weights to train becomes very large. In that case, what they have done is they have used a binary tree format. So in binary tree format, what will happen? So you will have like this. It starts out, then you have here, then again you have more, and then more, and so on. Let's just keep it here till now. So let's suppose these are the number of words that we will be using. This is 1, 2, 3, and 4, 5, 6, 7, and 8. Okay, so these are the different words. So here what will happen first, your input will go in, your output will go in here, and it will say whether it belongs to the first half, the word belongs to the first half or the second half. Instead of predicting all the softmax values for all these different words, it will just say whether it belongs to the first half or second half. If it belongs to the first half, these number of values or the values for all these words, those probabilities we don't have to calculate. Hence it will reduce by optimization. It will reduce the amount of complexity, the number of weights required. Alright, so this is one of the things that is used here. So that is it. I hope you understand the video. I know this was a long one and it taught about a lot of things. So take your time, go slowly, understand everything, and I hope that is it, and keep learning.